Hello, welcome to the first module for the AP CSA review, where I'll just be diving into some of the bigger concepts and providing, at first, some kind of a lecture, as this is, and then after which I'll give a code kind of example, code with me portion as well. So let's just dive right into the first module, which is primitives. All right, so in this module, we're just going to be splitting it into two, where the first half is going to be just programming and arithmetic, and then the second half we're going to be talking about casting, logic, and any other pieces that are covered in the first module as well. So that being said, let's just talk about the broadest topic here, programming in Java, right? So what is Java? Java is a programming language, and if we take a step back, programming is just where we write instruction through code for like computers or machines or technology to do whatever we want it to do, granted that it's capable of executing that task. And Java has been used to make countless apps, programs, softwares. One of the most famous would be Minecraft, which is made completely in Java. And another topic that isn't really super important for us, but something that we need to be mindful of, would be this topic of compilers, right? So how do we get from human code to machines that, this code that machines can understand, right? Because when you start writing Java, you're gonna see that it's very easy for a human to write it, very easy for a human to understand it, and so how does the computer really make this work? So for that, I'm going to be going on over here to my handy OneNote system over here. And I've already drawn it out, right? So let's say we have some Java code that says system.out.println. It's just a simple print statement over here. And what's going to happen is this over here is something that the human has written. And this is going to be then, compiled into machine code over here, right? These binary values are just random, but let's just pretend that means system.out.println. And then this is going to be then sent to the CPU, which is then going to be executing it, right? E for execution, and then sending the result back up here so that we can finally see the console print out hello world, right? So this is just like a higher overview of what's happening, but what we need to understand is that Java code is compiled into machine code, which is then understood by our CPU. All right, so we are then go back here. All right, and now let's talk about just some of the terminology that we're going to be encountering in our class, right? So we have classes, methods, class files, keywords, and statements. So classes and class files, really, they both go together in the sense that we have files, right? Let's just call one trial.java, and within that you're going to have a class called trial. So again, the name of the file and the name of the class have to match exactly, including capitalization and everything. And that is, that's just how Java semantics work. And also, there's this idea of driver classes. So driver classes is when we talk about more higher level things such as object-oriented programming, where you're going to have multiple classes and multiple class files. And within this, you're going to have a single class that contains something called the main method. You can only have one main method, and this main method is going to be kind of the drop that creates the ripple effect, right? So we're going to start off by executing the main method, and that method is always executed first. Doesn't matter if you put it first, last, in a file called read this last or do this first or whatever. The main method is always going to be executed first. Which brings me to our next bullet point, which is just methods in general. So Again, I've briefly talked about what the main method is, but methods are essentially pieces of the sandwich. So if you think of Java code as a sandwich, methods are going to be the individual pieces, right? You have the lettuce, the tomatoes, the onions, and pickles, if you like it like that. So the methods, they can be as long or as short as the programmer would like, as complex or as simple as the programmer would like. And when we go to module 2 and really start talking about methods, you'll see kind of what I mean by that. Class files I've already talked about, so I'll go to keywords, which are essentially words that are reserved by Java that you can't use for, say, variable names or method names or anything like that. So keywords examples would be like string or static or public, where you can't have a variable called public because that's a word that's reserved by Java. It means something completely different than what you're trying to say, and Java's not going to let you do that. And then finally, statements are basically there's just lines of code, right? So it could be as simple as a print statement or as complex as calling another method and storing the result in a variable, in a new variable, old variable, whatever it is. So let's talk about variables and data types, and this will be our last subsection for this video. So what are variables, right? These are values that you or the user can set, and this is something that you can determine by your code. You can set it, we call this hard coding, and an example would be, let's say I have a variable called age, right? So int age is equal to 19. That's always going to be 19. It doesn't matter if you're using it, I'm using it, somebody's grandfather is using it. The age is always going to be 19 because it's hard coded in there. They can also be set by the user, where you can ask the user like, hey, how old are you? And then if somebody else is using it, they can put in their age. I'll put in 19, somebody else could put 30, and that'll be the value that's stored. And it's just like math, right? You can manipulate these variables, you can add with them, subtract with them, granted that they're the correct data type, which brings me to my next slide over here, which are data types. So we have two main categories of data types. We have primitives and we have references. So primitives are going to be numbers such as ints, floats, doubles, or booleans, which are just true or false values. And on the other hand, we have references, which one of the biggest examples and one of the earliest things that you're going to be working with are strings. So let's hop on over to OneNote where I can show you more about references and primitives. So let's assume that we have int x is equal to 10, right? This is just a simple Java initialization statement where we're setting variable x to 10. So if we hop on over here to memory, x is actually not 11, x would be 10, right? And what's going to happen is when we go on over to memory over here and we see, okay, variable x, okay, cool. The value that it's holding is 10. And that's why it's a primitive, because all it does is it holds the exact value, right? If it's int x is equal to 12, right, it's going to be storing 12 here. X is going to be storing 12. References are a little different in the sense that, let's say we have string x is equal to 10. Well, string x, right, notice the double quotes over here, that makes it a string. So when we look at x in memory when it's a string, well, in this case it's holding a memory address, right, this hexadecimal memory address. And what that's going to be doing is it's going to be pointing to 10, right? So it's essentially a pointer. That's why it's a reference, because when you go and look at x, it's actually referring to another location. In this case, it's holding 10. Now let's say that I rewrite this, and instead of x is equal to 10, we write x is equal to 11, right? So what's going to happen is when we go on over here to see what x in the memory is holding, instead of 79, let's say it's going to be 75, and it's going to be a new memory address. And now what's going to happen is it's going to be pointing to this over here where x is equal to 11, right? But you see that there's still this 10 value in memory. It's not erased yet, right? If here I wrote int x is equal to, instead of 10, if I wrote 11, right, and we go on over here, well, what's going to happen is x isn't going to be 10 anymore. It's going to be 11, and there's going to be no form of 10 in that memory because 10 never existed. It's overwritten. Whereas in the string, because it's a reference, it's still here. You're just not able to see it. So that's why we say that strings and other reference types are immutable, because you can't change them. You really just make another copy and have that pointer point to that new copy. So that original 10, it's still there in memory. Okay, and that will be the end of this one. In our next video, we're gonna talk about setting variables and doing arithmetic with them. So stick around, and thank you.